Swinburne University of Technology.
Thank you. Look, firstly, thank you. It's your lunchtime, so I do appreciate the fact that you're here. Secondly, thanks to John Alnacinda for the opportunity for me to actually be here and have a bit of a discussion with you. And maybe before I start, what I wanted to do was maybe just give you a bit of an understanding of who I am within Cisco, what I do. So I come originally from an electrical engineering background. I've been lucky that I've actually jumped between the electrical world and the IT world throughout my career, and I've been fortunate enough to live in quite a few places around the world. I was in London for 7 years, Scotland for about 7, and I've been almost in Australia for 8 years now. I've been with Cisco for the last 4 years, and I've been through various organizations. I've worked in pharmaceuticals, oil and gas, government, finance, so I've had a really good run around the world and been fortunate enough to work for very good organizations as well. What I wanted to do is maybe get a bit of an understanding from yourselves on what do you know about the Internet of Things or the Internet of Everything. Does anybody know what that is or heard of it? Yep. You have a bit of an understanding of what it means or the difference between the two?
Yes.
Well, that's good.
I understand, so I'm here to make sure that
Okay.
the basics are right.
You'll be one of the few. You'd be amazed at how many places I speak that people have heard the concepts, but it's actually quite interesting that if you look at you read the Financial Review these days, you'll find these comments inside, the Age has them in there. So what I'm going to do today is probably talk about, number one, what's the actual reality out there within the world, what's the opportunity for organizations. What I'm going to try and do is talk a little bit about what does it actually mean for an education institution like yourselves. Some of the things that Cisco is actually doing with you guys at the moment. We have some programs that we're actually starting off with you around this space. And then I want to talk a little bit about the risk of not getting involved in this space and also talk about some of the other universities around the world and some of the things that they're doing with us as an organization. So first of all, I'm going to try and demystify a little bit between what's the difference between, if my mouse works, the Internet of Things and the Internet of Everything, and what's the vision or the marketing spiel that's actually been put out in this space. So the Internet of Things comes down to stuff that connects onto computer networks, and that can be anything that connects to a computer network, right? And I define the world into three different versions of this. So there's the consumer world, there's the public sector world, so that would be healthcare, education, governments, councils and things. And then there would be the commercial world. So that could be anything from a retail world or anything to do with things like a manufacturing organization, etc. So they have specific requirements on what they want to connect onto computer networks. And why is this so important for an organization like Cisco? So Cisco builds computer networks, and if you want to connect something to a computer network, well, you need to get it onto something, so it's a bit of a chicken and egg situation. So for us, it's in all these sectors around the world that people are going to be connecting more and more devices onto it. This is where we see the opportunity for us as an organization. And to give you some idea of some of the things that people are trying to connect onto computer networks, this is a smart salad packaging, right? So what this does is it actually has an electronic sensor inside the packaging, and there's actually a printer that prints that packaging. And what it does, instead of telling you the date on the salad, and you throw the salad away based on the date, it actually tracks the transportation of that product all the way through to your house and tells you how well it was refrigerated or not, and then it'll change color to tell you if the salad is good or bad for you. So a lot of retail organizations are very interested in this. Coles, those type of organizations want to actually take some of this technology and utilize that, because then instead of the stamp that's been put on a meat product that's being shipped from a slaughterhouse, they can actually track how well it was actually transported to your house, and then it tells you if it's good or bad for you to eat. So just stopping them from throwing away waste. There's a lot of stuff going on in this space as well. So smart dust. Has anybody heard of smart dust? So, all right. So there's smart dust out there. There's organizations now that want to take dust particles, put it into agriculture, into a field, and be able to monitor how well that field has actually been fertilized, or how much moisture is in the ground, and then you can actually take that data back in real time. And we're talking about millions of these little things being actually spread across agriculture. So that's kind of an application within the agriculture space. And then, like I mentioned before, the jawbones or the Fitbits is another really big space that people are very interested in. And that's more in the consumer world. There's also a very large play within the defense world and security world in this space as well. I was lucky enough to hold a little router, everybody like the ADSL modem that you have at home, a little one that big that the American Marines are now actually wearing within their backpacks, so that you can actually have a smart connected battlefield so people can actually understand which skill set is on the battlefield in real time. And all of that type of stuff is out there today. So what it comes down to in this Internet of Things world is if there's power connected to it, or if it has a battery inside it, you can connect it to a computer network. And once you connect something to a computer network, you can monitor it. Once you can monitor it, you can manage it. And once you can manage it, you can actually turn it into something that becomes autonomous. And that's the pinnacle of evolution, is where we can actually get sensors to make decisions based on information that they gather around things that's happening around them, and then take action against that, so and not needing a human to actually make that happen, right? So there's this big shift going on connecting the unconnected devices in the world. And from a perspective of Cisco, so where does that Internet of Things become a reality? Well, the Internet of Things, the word or the phrase, was actually coined in America in 1999. So depending on what you read on the internet, it's either MIT, professor at MIT, or somebody at Procter & Gamble that actually coined the phrase. And what they meant was, you will have this point in the world that there will be more devices connected to the computer networks in the world than what there are people on the planet. So between 2008 and 2009, there was about 7.2 billion people on the planet, and then all of a sudden we got to a point where there were more things connected to computer networks. So the prediction at this moment in time, and my personal opinion is that's actually below what I estimated would be, but at the moment they believe there will be 50 billion things connected to computer networks by 2020. So 50 billion things creating data, and the uptake of that is 5 times faster than what people took on electricity or the telephone. Now, what that all needs at the end of the day is a new essential application and infrastructure to control it. I say to a few people, the reality is, think of what apps have become today. Is there an app that can do your job? Is there an app that can do that job? So once you have an application that links to a piece of technology, then you can actually utilize that significantly to change processes within organizations. And just to give you a little bit of an understanding, so this is actually out of the Harvard Business Review, and one of the things that's happened in the last, say, 60 or 70 years is we've had these 3 massive waves of how information technology has been applied. So the first wave was when we took away the typing pool and replaced people that used a lot of paper and vocal communication in a supply chain, and we actually put a mainframe computer in that place. It's very ironic how things move out and move back again. So you had a mainframe computer with a whole bunch of cables connected to PCs at the end of it, and then all of a sudden everybody got a personal computer, and now everybody's trying to put everything back in the cloud again, which seems to it just repeats itself. And once we got past the 1960s to the 1980s, where that first wave happened, the second wave was the e-commerce, the change in the world. That I remember in 1995, I worked for British Telecom in the UK. I went and installed Mosaic, which was the first internet browser back in those days, on a director of British Telecom's PC, his Windows for Workgroups 3.11. And I put it on there, and he said to me, right, what can I do with this? And I went, well, the only website that I know of that's worth anything is NASA's website. So we went to NASA's website. He clicked through it a couple of times. He said, oh, it's rubbish, get it off my machine. Today, you would not be able to exist as a business if you did not have some sort of e-commerce platform that people can interact with. So the third wave is the smart connected product world. So we have Komatsu trucks running around the Pilbara today that have no drivers in them, right? So they actually use a Wi-Fi network, and they run around that mining environment. And what we've done is actually create a platform across the mine for them to connect more and more devices on. And it's probably one of those interesting stages on how things are developing. Those first 2 waves was all about how you change the supply chain and productivity of people. But the really next big wave that we see is every single thing that has power connected to it will have the ability to be connected to a computer network and monitored, controlled, and managed. And that intelligence if you look at a farming environment, so if you have a tractor, yeah, and then you have a tractor that has a graphical interface that you can do something on that tractor, then you take that tractor and you actually then connect it to a computer network or to a 3G solution, then now you can take the driver out of it. And when you actually connect all the other implements on the farm, then you can actually start looking at that ecosystem on how they all interact with each other. And that's how these waves are working. So you work from a product, then you have a product that has some sort of intelligence in it, then you have a smart connected product, and then you end up in this third wave where we will see more and more things having the ability to connect onto computer networks. So that kind of gives you an understanding of the Internet of Things. The Internet of Everything is 4 things that happen at the same time. So I talk about market transitions. So a market transition is when you went from a Nokia 6210 phone to an iPhone. Yeah, that was going from one to the other. My wife is still very adamant that she would love to have a Nokia 6210 back, but anyway, yeah, the GSM network's turned off. So we've gone from this place where we expect 50 billion things to be connected to computer networks. Well, once you connect something to a computer network, it generates data. So the big challenge that the world is going to face over the next couple of years is how much big data is actually going to be created. And there's this paradigm that I talk about where it's big data versus little data. And I'll talk and tell you about a thing called fog computing, which is something that'll be very relevant to the university here. And it's that next wave of evolution where you can actually create an application that sits inside like the ADSL modem at your house, and you can actually control things at your home. So you might actually be able to pull an app for your alarm system or an app for your Miele refrigeration unit down into the ADSL modem at your house. And that's a new concept that's out in the space, and we're looking for a lot of universities to innovate around this space. Once you've actually got the data that's been created, well, now you have to have some smart guy with some sort of analytics career behind him to analyze that data and change the processes and how those things work. And once you've done that, the social component, or how that interacts with people, is the application. So we talk about the killer application within a business. How can you get all the information in a manufacturing environment from the ERP system, the manufacturing or the line, plus cost of energy, the cost of a resource in front of a director or a CIO in an organization in a single application that he can make a on-the-spot decision on what time he actually closes his plant today, and he can actually fulfill his orders. And that's the type of information that we're seeing crossing between boundaries, and I'll talk a little bit about that as well. So at the end of the day, it's once again the network that connects all these devices. So I mentioned this a little bit earlier, and this is kind of how we see the evolution of all that big data is. Well, what you have to do is take all that big data that's sitting inside data centers and turn it into information. And once you got it to a point where it becomes relevant business knowledge, then you can actually turn it into some sort of wisdom to change organizations. And a lot of companies are now trying to understand how do they tap all that big data that they've been keeping for all these years and turn it into something that can actually transform their business. So a really good example is, and this one is really relevant for a university campus. So remember at the beginning I said I'll talk a little bit about what some of the university campuses are doing around the world. We see a big driver around smart cities. So today there's an estimate of about 100 cities around the world that's gone into this, what they call smart city platform. And what they're trying to do is actually look at how they integrate things like waste management, traffic systems, Wi-Fi for citizens, how they actually integrate things like lighting control, physical security and safety for people within the city, and how do they actually bring all of those things together across a ubiquitous platform for them. We're talking to organizations in Australia that's very interested in taking the healthcare that they have within a hospital and extending it out inside their community so that people can actually stay at home and have home healthcare, but being monitored in real time across a computer network with a device that actually monitors their health rather than actually bringing them back into a hospital. And one of the things that we see in this space is, well, you have to have cloud services and all these smart components interconnecting all these systems. And to give you an example of what that actually means for a city, in Barcelona, we've deployed smart lighting, buses, smart water systems, parking systems, and literally linked it into a platform that the citizens can actually get access to some of that data as well. And what does it actually mean for the city is, and this is the really important bit, it's actually created 56,000 jobs within the city. Barcelona was actually one of those places that had a really big challenge with young people that weren't employed, and what they had to do was actually put in place some sort of mechanism to do that. Now, bring this all the way back to Australia, you have places like Geelong and places like Adelaide that have lost a lot of the manufacturing without industries in their location. And one of the things that we're trying to do is work with the local councils and the cities to try and figure out how on earth we're going to help these people create jobs. So once you put a smart infrastructure across a city, so if we take your campus as an example, if you can actually link a field area network, so a field area network is something that connects sensors to it, plus a Wi-Fi network across your campus, and be able to monitor the footfall of where students come from, be able to work out where students are congregating at what time of the day. You just had a fire alarm, maybe some of you were in that, in a building 2 or 3 blocks that way. It was inside your campus, so there's a fire alarm in there. If you had the ability to understand if there was a phone left on a desk upstairs that the building was not evacuated, but you can actually monitor that in real time just by the sheer fact that the phone was trying to connect onto the wireless network, that will actually help people from a safety and security perspective. So what we're looking at is how do you actually build a smart city solution across the campus, because it gives you the ability to look at your waste management systems, it gives it the ability to monitor and manage your parking solutions, and gives you the ability to look at how you do energy management. There's a university in Australia that told us that their current electricity bill is, I got to get this right, $70 million a year that they pay on electricity fees, and they are trying to figure out a way on how do they actually put technology across their campus that actually will help them to reduce that energy bill. So if you had a smart energy system within a building, you could actually control lighting in a more effective way. So there's a lot of use cases that we're looking at in this space, and what we're looking at, for example, in manufacturing is people want to drive efficiency, operational efficiency. In cities, they're looking a lot at things like revenue generation, and in transportation, they're looking at changing the customer experience. But once you actually get one of those applications inside an environment, you can actually then put a lot more of these solutions across it. So that kind of gives you a vision of what's happening around the world and some of the an understanding of what some of the cities are doing, but the reality of what's happening out in the market space. So Gartner has predicted, that there's a $1.9 trillion revenue target against this market by 2020. IDC also refers to the third platform as a $462 billion opportunity. And the industrial Ethernet, so GE, any of you ever flown on a plane? Most of the planes around the world, especially the new ones, have a GE jet engine in them. GE have actually put a statement out in the market that said if they can monitor in real time the jet engines that are flying in their planes around the world and be able to tweak the energy efficiency on how it uses fuel in real time, they'll be able to save the world $1 billion in fuel costs over 3 years. So that's the difference of what you can apply once you have something connected in real time rather than waiting for a maintenance window to go and fix that engine. So at the end of the day, there's this unique inflection point that's happening out there at the minute on all these things being connected to computer networks and being able to utilize the data that they actually generate. So Forbes actually put out a statement in August this year that said the Internet of Things is now a bigger hype than what big data is. And one of the things that we're seeing is that hype is just going to continue going up. I don't know if any of you guys read the Harvard Business Review. There's actually some really, really good articles in there about the disruption in this space at the moment that's coming out from connecting things to computer networks and how that's fundamentally going to actually change how businesses do business. And to give you a little bit of an understanding of what the awareness of things like CIOs in companies are. So we had a look at IT executives across the world, and 91% of them in Asia Pacific actually said that they have an awareness of this. And when you look at the actual industries that they're looking to apply this, so the utilities industry is very, very unique in this space. Cisco has just worked with a state in Australia to actually build a sensor network across the whole state. And what we're actually going to be doing is our software, what we're running on the smart meter that sits inside your house, and be able to monitor and control that. one of the biggest reasons that this energy utility wanted to do this is when they had a massive outage, power outage, they could not actually see how many houses were affected, and what they wanted to do was get real-time information from the smart meters at people's homes to be able to send the vans in the right location and understand which power substation has gone down. I've been in New Zealand probably about 6 or 7 weeks ago, and they had a massive power outage that took them 10 hours to sort it out just because they did not have real-time data to figure out where it was all going wrong. So a lot of the utilities are very interested in this space. The oil and gas industry is also very interested in driving this. And manufacturing, being able to get real-time data out of a manufacturing environment has always been possible. They've always done that, but actually taking that and turning it into business knowledge that a CEO can make a decision in real time on when to stop and start lines based on energy cost, resource cost, and how many orders he has in his system is something that they're looking for in real time now. And the retail industry is a really interesting one. And funny enough, the finance industry is not listed up there because they see this whole thing as a massive disruption to them, right? The finance industry is probably one of the industries, and especially in Australia, ironically enough, because they make so much money, that everybody wants to disrupt them. So. And then who's actually going to do something about this? So these guys all know about it. Well, what are they going to do? 92% of the participants in Asia Pacific actually said they will actually be doing something with it about connecting more devices onto their computer networks and doing something with all that data that comes out of it within the next 3 years. The oil and gas industry, so we had our mining boom. The really big thing that's driving a lot of innovation and from a revenue perspective for Australia at the moment is the gas fuels that's going in Queensland and things like that. So there's a lot of innovation that we're seeing. They want to put CCTV cameras on wellheads, all of those type of things what they would have never done before. And the ability to have a mobile worker come out into a gas field and be able to connect in real time back to his network and do all the data analytics with all the systems around him, telling him in real time what's happening. We're seeing a lot of innovation being driven in that space. And the utility industry in Australia is very keen on deploying more and more technology. So what has actually happened around the world? Unfortunately, that screen's a bit skewed. But we've actually seen a lot of organisations drive a lot of funding into this space. I mean, the UK has actually announced a £45 million plan to actually go and invest money into IoT, or Internet of Things innovation. We've seen really big acquisitions in the last while as well. So does anybody know what Nest is? So Nest is a temperature sensor that was purchased by Google. And what this does is you take the original temperature sensor that does your heating and cooling out from your system at home, and you swap it with this little Nest controller. You put it on, and what it does, it is actually monitors how you utilize your house. So it'll actually work out when you're in the home, when you're not in the house, and it connects to the internet as well. So you can sit here with an app on your iPhone and you can control the Nest system to turn on and off your heating. But it took it one step further. It can even tell you when there's an intruder in your house. They've taken the smoke alarm and changed that into a little LED device that can then monitor movement, can detect gas leaks, can detect smoke leaks, all of those type of things. So these guys were bought for $3.2 billion. There was not that many guys in the company. I think there was about 20 or 30 of them in the company, so I could be corrected on that, but there was not many guys in the company. The big thing, a lot of you guys might remember the year 2000 when we had all these big bubbles in the IT world and the IT bubble burst. Well, this is probably one of the big risks within this space as well, that there's so many of these companies that's actually out there now that are being snapped up for millions and millions of dollars that's actually got no value behind them at the moment. It's still very conceptual. But to put it into perspective, on October 14th, 2013, we expected there was about 10 billion things connected to computer networks. The reality is, today, in October 2014, there's about 13 billion things connected to computer networks. So to put that in perspective, today, every single second that we're sitting here, 99 new things, not phones, things that are actually producing data like a door lock or a CCTV camera is connecting to a network, so 99 per second. So by 2020, we expect that number to go up to 255 per second connecting onto computer networks. So to put that in perspective, this year we anticipate about 3 billion new things would have been connected to computer networks. By 2020, there'll be 8 billion things connecting in 1 year to computer networks. So these numbers are quite staggering. So what is the opportunity out there, and what is one of the big things that we see is the big shift? So from an education perspective, what is the big shift that we're seeing out in the industry? So the traditional information technology or IT side of businesses, Cisco has done millions of dollars of business in this space for many, many years. The reality is we're seeing the shift from an operation technology world to an information technology world that they're amalgamating. So BHP Billiton in Australia, from an iron ore perspective, they took their operational technology guys that manage mines, plus the IT group, and they amalgamated them into one group, and they call them information management. If you had to imagine what that would be like for your organization here, you would take your campus facilities management group and your IT group and put them into one group, right? And call them information management for your campus. And one of the big shifts why that's happening is traditionally, you would have, any of you gone through a door where you have to buzz a button and somebody buzzes it to open the door for you? Well, that device was connected by 2 wires and maybe used 12 or 24 volts. What's happening now is the computer network has the ability to provide power over Ethernet across a cable. So all these IP phones that you guys have work with power over Ethernet. So what you can do is you can take that power and actually put it into a door lock. But once you get connected to the door lock, you can then actually control it via an application because it's connected to a network. So we're seeing a lot more things becoming Ethernet enabled. We're seeing a lot more virtualization in the operational technology world. So they used to have multiple devices. And what they would do is virtualize that now into, like we did in the IT world, they're virtualizing a lot of their applications as well. So these two worlds are integrating with each other. So a good example was if you looked at that mining environment that I showed where you have a Komatsu truck which has now actually got all the software on it and no driver, you need a mechanical engineer, electrical engineer, and a software engineer. So that can look after 10 of those vehicles. Where today you would have one software engineer and he might be based in Perth and never ever go up to the Pilbara. But now you'll have to have those guys locally on site. So there's this change in the education process that you need a lot more people that understand software because more and more of these devices are going to become autonomous. So this convergence of IT and OT is creating new value that we see out in the market space. And one of the things that we are seeing is if I go and stand in front of a customer and want to talk to him about spending money on IT, so if I go to the IT department, the only thing that the IT department tells me now is they get less budget every year, right? The people that actually do get the money is the operational technology people, right? So if I go to a mining operator and he asks me for $1 million, I can give him $1 million, he'll give me another 1 million tons of iron ore. If I go to the IT guy, I give him $1 million and all he asks me for next year is another $1 million, right? So there's this big shift happening in the market that the line of business owners are the people that are actually making the decision on what IT products are being purchased. So an example would be, unless I can actually give better asset utilization to an organization. So there's 2 very large transport companies in Australia. One of them came to us and said, how on earth can we get real-time information out of our big trucks running around on the roads and be able to utilize that? So what they did is they put like a little modem, 3G connected device inside their trucks, and they can monitor where the truck is, how the refrigeration unit is working, what the tire pressure is, how long the driver's been driving, what's the average speed that he's been driving. And then they take all of that information into their data center, and what they came up with is they said, well, we can get 5% better asset utilization out of the truck, plus we can get better utilization out of the driver. And if we can do that 5% better than our competition, that's really good for us, because if you take into account, it can cost up to $30,000 a day to have one of those big W trucks on the road. So if I can make 5% cost saving to my competition, I'm willing to spend the money to actually deploy the IT technology. And this is why these 5 key drivers is a lot of the conversation that we're having today. Unless there's a specific business outcome that you're trying to drive for the customer, they will not actually spend the money on IT. So, as I mentioned before, these are the things that are actually driving the innovation within that space. So it's the virtualization of the applications, so real-time applications and an open platform, I/O devices or 2-wire connection to IP, power over Ethernet is one of the other ones. So in a manufacturing environment, as an example, we have manufacturers that want to be able to look at that ERP system. They want to look at the logistics and transport system, the cost of their labor and the cost of electricity. And if I work out that I can actually stop my staff at 3 o'clock on a Friday and send them home, and not run my plant for 2 hours, but run my plant for 80% on a Saturday, but save myself $25,000 in electricity costs because it's cheaper for me to run my plant on a Saturday, then that's the type of decisions that these guys want to be able to make. So smoothing out the cost and the energy usage based on what they can do. So this is the real big change in the market, and this is one that's really important for the education industry. Somebody, ironically enough, wrote an article. They interviewed one of the guys at Cisco, and he put up frog computing. So there's all these articles flying around frog computing, and all the guys in Cisco took it as a real joke. So I can just show you some of the emails with frogs on it and everything. But anyway, so everybody wants to take everything to the cloud. I don't think anybody here has not heard what the cloud is, because if even in a social platform, if you have your iPhone and they get hacked, and some people have strange photographs on their iPhones, but anyway, yeah, all of that stuff gets hacked because people put it in the cloud. But what Cisco is saying is, if you put 50 billion things onto computer networks, the reality is some of those places might be in very remote locations, and what you have to do is bring all that data back. Well, bringing all that data back to a data center is probably not the best thing to do, because a lot of that data is going to be predictional. So what we've said is you need a 3-tier model. You're going to have devices at the end. You're going to have fog computing, and obviously some smart ass thought of that. You know, cloud. If you have the cloud, what's below cloud? Fog. There you go. So that's all it stands for, is fog. There's no other reason for it. And how's that going to change the way applications are being rolled out? So today, you usually have 3 platforms. You have a networking platform, you have a compute platform, and you have a storage platform. And what you want to do is actually change the way how you actually look at your data. So today we store it, then we analyze it, and then we act on it and notify it. So the finance industry is a really good example here. They will store the data, they will analyze it, and then, according to the ANZ, they will be able to predict 2 years in the future when you will get divorced based on your credit card spending. So the trick is, have more than one credit card. Or don't get divorced. But, or the other thing that we're saying is, well, if you can analyze the data as close to the source as possible, notify somebody to do something, then he can act on that data, and all you do is you store the actual result. That's the change that we see in the market. So if you can imagine having the ability to drag an application, just like you drag onto your iPhone, into a router, and being able to monitor a sensor. So a good example was, we're working with some of the big dairy farms in New Zealand. To pasteurize milk, I think, I'm right here, 76 degrees Celsius is what it takes to pasteurize milk. So if you have a temperature sensor inside a pasteurization unit that has to keep the milk at 76 degrees Celsius all the time, what's the point of taking the data from that sensor and sending it all the way back to a data center and storing all of it? There's no point in doing that. So what you really want to be able to do is analyze the data as close to the point, the router, look at it and say, well, all the data is what it's supposed to be for the last 24 hours. I'm going to send one message up to the cloud and say, everything's been fine for 24 hours, don't worry about it. But as soon as that temperature sensor goes to 80 degrees Celsius, all of a sudden the router analyzes the data and says, well, hang on a second, that's not right. It's supposed to be 76 degrees Celsius. And if John was looking after the pasteurization system, it'll actually notify him directly to go and do something about it. And that takes all that compute that happened in the data center and puts it into an application and pushes it right at the edge. So where's the value in that for an educational institution like yourselves? Well, Cisco's never going to write the apps. So we've actually created a platform that you guys can actually get your students to write the applications on it. Now, going back to that story, if you actually turn your campus into a smart city type of environment and actually put a platform in place here that your students can actually build real-time solutions by using technology and sensors, because think of it, every single one of the things that you have power connected to is inevitably going to connect to a computer network. Being able to use this as a platform for innovation, that's where we see the next wave of education is going. So it's not so much as actually knowing or having all the knowledge, but it's actually being able to understand it and analyze it in real time. And that's what we see as the next big potential for education institutions and getting their students to write those applications. So to give you an understanding on how we're doing that at the moment, so we've got a box out here. This one's going out into one of the states in Australia right now for that energy utility. This box here can have 5,000 sensors connect back to it. So think of 5,000 electricity meters connect back to this box. And what happens is Cisco has actually worked in partnership with organizations now that we can actually put our software right onto the end device. So you think of Cisco software running right here and connecting back to this device. And what happens is when there's a power outage, instead of 5,000 messages going back to the electricity utility, that little box actually consolidates all the information and says it's streets A, B, C, and D, and this is the substation that's down, and sends one single message to the, and they go, well, this is where the vans have to go fix the problem. So this is one of the big changes that we see, that application is being pushed out to the edge, and that's how fog computing really works, is being able to push those devices out. So the other thing that might be of real interest to you guys is where's all the industry partnerships that Cisco is working at. So this is a snapshot of some of the organizations that I look after and work with in Australia, and some of the ones that we have global partnerships with. So think of these guys as the new IBMs and the new Dimension Datas and the new big IT companies, because what's happening is a lot of this operational technology guys are moving across into the IT space, and they are actually the people that are actually owning and controlling the relationships now, rather than the other way around. So Rockwell Automation works in the water industry, they work in the manufacturing. Anything with a bottling line or anything that has a line on it, needs a drive on it, they'll work in that space. Honeywell, by example, Cisco is almost a $49 billion company. Honeywell is a $39.6 billion company. They are absolutely massive, and you might have an alarm system in your house or whatever it might be. Siemens is a really, really big company as well that play in this space. They're looking at smart traffic systems, smart lighting systems. Schneider Electric have a smart city initiative with Cisco in Barcelona that we've jointly put 37 million euros worth of funding into to drive innovation within this space. And then there's a whole bunch of companies in here, organizations like GHD. Does anybody know GHD? So they're one of the biggest civil engineering companies. They build almost every single airport that's being built these days. They would either be bidding for or busy building them. They did San Francisco's new airport. These guys are civil engineers, but they're geologists as well. So today they would be responsible for Gina Reinhardt's new mine in Western Australia, building that whole mine or doing the architecture for it. But what they do today is they do water, gas, and electricity. We're working with them now that they're going, it's water, gas, electricity, and IP. So how do you put a computer network across all of those things that you're putting in place from the ground up and actually connect it from day one? There's a statement that I use, it's called built in, not bolt on, BINBO, right? So you've got to build it in from day one rather than bolting it on later. So these are some of the organizations that I would really think that an organization like a university would want to form partnerships with, because they have a massive opportunity for you guys to work with them in this space, because they're trying to bridge that gap between the IT and operational technology world. And believe me, they don't necessarily have all the skills. And they will probably be some of the biggest employers out in this field at the moment. So how are we working with these organizations? So what we do is we've actually broken down the verticals on what we believe the markets are, and then we look at the industry partners that actually hold most of those relationships. So Emerson, for example, pumping stations. So if you have a pumping station, they would do a lot of work in pumping stations. ABB, every single power substation in Australia, they would probably have some sort of relevance in. They work, Siemens as well. So ABB would do all Rio Tinto's mines and power substations. So Cisco has been working with them to actually put our technology out there with them. We work with organizations like Itron that actually builds the smart metering. Schneider Electric is another example. And what we do is we then go and take their solution and combine it as an architecture. So I don't know if anybody has ever heard of Cisco validated designs. We used to have all these designs. If you put one of these telephone systems into an organization, if you do it to this specification and follow all these configurations, then we guarantee it'll work. So what we're doing with these organizations is we're building these validated designs with them as well. So what we do is we go look at the industries, we look at the verticals, and then we go look at actual outcomes for customers. So a connected factory solution, a connected mine, connected rail, fleet, utilities. So if you look back at those slides at the beginning, who's some of the guys that's going to spend most of the money in this space and innovation, that's some of the organizations that we're working with. And then what we then do is we create a vertical use case in every single one of those. So obviously in Australia, the mining industry, the factory industry, utility, oil and gas, We have now got a wireless solution across the city of Adelaide. So the city of Adelaide was one of the first cities in Australia to have free Wi-Fi across the whole city centre. The next step with them is we're actually working with Flinders University out there to actually help them now put technology across it. So that Internet of Everything Innovation Hub, we're actually launching an Internet of Everything Innovation Hub with Swinburne University at the moment as well. And what we're trying to do is actually drive innovation in this space and how they might be able to utilise, for example, that network in Adelaide for waste management or traffic monitoring, etc. There we have vertical solutions based with partners, so we can actually go out there and speak to a customer about that. So I suppose what I wanted to do is, talk to you about, do you think that there's an opportunity for turning your campus into a smart city, or a solution like that to actually utilise that as an innovation hub for your students to actually work with all some of these strange partners to do that? The other one would be, new partnerships for you guys are really essential. I work with all those Honeywells and Rockwells and things. They come to me and say, we know Cisco puts 50,000 students, 25,000 students, let me get that right, through network academies in Australia alone every single year. How can we become part of those network academies and have Rockwell or Honeywell stand as part of your education and speak to these students around, well, we do all these amazing things in the mining, gas, oil, building, architecture industries. How can we actually work with an education institution like yourselves to actually bring some of your students to think that, well, it's really cool to go work for Google and it's really cool to go work for Amazon and all these guys, but there's absolutely brilliant careers that they can have within these organizations as well. So that's something we can talk about. They'd be very keen to work with you. I know Rockwell Automation has a academy program as well that they would be interested in discussing with yourselves as well. And that's probably as far as next steps goes. But then probably the one thing I would like to leave you with, in this game, this Internet of Things and Internet of Everything, I'd really believe that this is the really big disruption out in the market space now. I think that either you're going to be somebody that's disrupted, and even the education process within universities is fundamentally changing. There's a whole bunch of statements out there on how we see the technology is going to change on how students are actually educated. So, and that plays into this Internet of Everything space as well. But you're either going to be the organisation that gets disrupted by this technology, or you're going to be the one that actually takes this technology and disrupts your competition. And that's kind of where I think the reality is in the market at the moment. So that gives you a very broad snapshot, and I know there's a lot of content in there. I talk really fast, but then I say people listen slow as well. But is there any questions you guys have got or would like to know more about a specific topic? Relevance, not relevant? Matt?
Sort of treating people as pawns a lot in your sort of philosophy of this, because people can shift to Saturdays and people can lose their jobs driving trucks, and truck drivers have got to be monitored, and so you're de-skilling a lot of people at the bottom within this framework. Have you ever considered the social impact of this relentless onslaught?
Yeah, look, I think that's a very good question. So I think one of the big changes in the market space is there's going to be a lot of de-skilling. I completely agree on that, but there's going to be re-skilling. So an example would be, we need, the Americas believed that today that they need 1 million analysts. There's a shortage of 1 million analysts in the market in America alone that has to go through all this data. So just like the Industrial Revolution fundamentally changed what happened in a farming community and everybody moved up one step, I think this is the really third wave of people changing their careers into the next evolution of what people are going to do. So there's definitely going to be people that will lose their jobs, but I think also there's going to be lots of opportunities for people to reskill themselves. Because, I mean, if you are a driver on a mining environment today, actually what's happening is some of those guys are actually not going up to the mine anymore. We're pulling them back into an operations center that the guy can actually remotely sit and control the vehicle from, and he doesn't have to go away from his family. So there's definitely a shift on how the technology is changing people's jobs, definitely.
There must be a net loss of jobs. I mean, you're not going to replace 10 drivers with 10 software engineers.
Yep.
You replace 10 drivers with 3 software engineers.
Yep. Yeah. Look, I agree with you. I suppose the other thing is also that one of the things that we're trying to do with this is actually drive innovation to create new jobs in new industries, right? So, like I mentioned in Geelong, the manufacturing or the vehicle manufacturing industry that's going out of there, they have a massive hole of jobs that they have to fill. Deakin University is actually working with the city there around driving some sort of innovation and startup community to actually create new businesses that people can actually go and work in. But I agree with you, there is going to be a massive disruption within the market. Yeah.
You used as an example, though, that in Barcelona it created many jobs.
Yep.
So what sort of jobs did it create?
So in Barcelona, they stated that it created 56,000 jobs within the city. And one of the big challenges that they had is they had this huge demographic of kids that didn't actually have work, right? So by them putting this platform across their city, they've actually created a market where people are now looking at, I will rather go live in a smarter city that gives me technology to create innovation and have a startup business in. So there's a lot of startup funding and things being put in by the government as well to actually drive some of these things. Cisco's working in Canada to do a lot of this stuff at the moment as well. We've got a big innovation fund that we just announced in Ontario with the government there to actually help create jobs. So I think if I had a choice, if the traffic system in Melbourne was a smart traffic system and I immigrated to Australia and I had to look at Sydney and I had to look at Melbourne, believe me, I will choose the smarter city. And this is the big challenge that's happening in the world as well. There's now 100 cities that's trying to play in this space. And I think that is going to fundamentally change how people actually choose where to live as well. I had a meeting with my local council in Victoria. I won't name them. But I sat down with the mayor and said, look, my perception of dealing with you is I have no communication with you unless somebody has complained that I've done something wrong or I haven't paid something and my garbage gets taken, and I'm all happy about all of that, but I have almost no interaction with my council in real time. So if you put some technology in place that I can actually interact with you and you can deliver services to me across that, I would actually find that really beneficial, and you would be a smart council that I would want to live in. And that's some of the drivers that we're seeing as well. But these things are slowly but surely creating some jobs as well. So nobody's asked a really, really difficult question yet.
Okay. My name is Ziggy. So, difficult question, I'm not sure it's difficult, but how Cisco is responding to the new trend, which is Industry 4.0, which is a 12 months old concept when basically we are talking now about ecosystem of the production.
Yep.
Isn't any sort of the response from the Cisco to it? Or?
Look, so what we've been fundamentally doing is trying to underpin some of that ecosystems to make them interact with each other. And a lot of what we see in the industry is a lot of siloed solutions. So what we're trying to do is put everything on an open standard platform so that they can all interact with each other. We're working with an organisation out of Tasmania that have literally created a sensor solution for farms. And what they're trying to do with that solution is not just use it for one unique farm, they actually want to take certain data points out of every single farm and be able to share that with every single other farmer so that they can actually utilise the data, where a lot of the things that we see today, things get built very siloed. And where Cisco is trying to go with this space is we're trying to be working with the ISO, the IEEE, and creating new protocols and new open standards that data can actually be shared. An example would be the city of Chicago. Their mayor got elected by being completely transparent. You can go on our website today for the city of Chicago and they will share 300 data sets with you. One is every single salary for every single employee inside the council is on that website. Open data tells you all that information, because he said the difficult question I was alluding to is privacy. Yeah. What do we do about privacy within this space? And he said, well, in order for me to show you the information that I'm capturing, I will actually share the data points with you openly, and businesses can then use that data point. So I might be able to pick up what the footfall is in this area on a specific day and understand how many people are within that location. So that gives me an understanding from a town planning perspective. It might give me a retail perspective on how many people I might actually see in the area. Do I stay open? Do I stay closed? And that's some of the data that the people might be able to utilize back. And come back to your question, what are we trying to do in the industrial space? We're trying to create a very open platform that some of that data can actually be shared between organizations without actually siloing and closing it. Yeah.
50 billion devices, when you want to connect, you need to have 50 billion IP addresses.
Yep.
Which means that you have to go into an IP version 6
Yes.
system.
Yes.
Does it mean that all the other systems will also change into that? I mean, because you're running on IP version 4 now.
Yeah, look, NAT has been a wonderful thing to change IP addresses. So this is probably the biggest driver that I've ever seen for taking IP version 6 onto the next stage. Nothing else that anybody ever came up, and universities have been immaculate at actually adopting IP version 6 technology and deploying it very early, even 5-10 years ago. But this is probably the biggest driver for IP version 6. IP version 4 will always be there, I think, in the background somewhere, but this is the biggest driver for it. Yeah.
For networking is, computing is sort of the answer to it, where it doesn't need to make that big impact on the number of
Yep.
IP addresses, so it can be solved in the sort of the local area
Yep.
instead of sending it through across the world.
Yep. I mean, we're speaking to utilities in Australia that have 13 million meters, right? So 13 million meters, then there's 13 million water meters, then there's 30 million gas meters. And that's just the meters. But once you build this network, then you can have temperature sensors, you can have agricultural sensors, you can, it just becomes a massive, massive deployment of technology that can be utilized to bring data back. So.
I'm just sitting here and I've got this funny feeling, a bit uneasy, that the world's going to devolve into these two areas. So, I mean, are you working in developing countries? Are you working in Africa? I mean,
Yeah.
and it's all about, what was interesting was you talked right at the beginning, one of the slides was, if there's power, and I was thinking the other day, if something happened and suddenly we didn't have power, we'd be stuck.
Oh yeah, look, I can't answer that question, but, so a very, very good point. The organisation that we're working with out of Tasmania is actually a company called Sense-T. They were spun out of the university in UTAS. They're now called Sense-Co. They've actually gone and created a solar-powered sensor network that uses a solar power solution that it takes such little power to actually drive these little sensors that go in the ground to measure moisture. And what they've done is they've actually gone to the World Bank, and we're working with them at the moment to help them put this together, that they can go to developing countries around the world, and for a fixed price, I'm going to throw a figure out here, say $5,000, they can provide a kit that gives you X amount of sensors above ground and X amount of sensors below ground, and you plug it in, you put it onto a solar panel, and it works, and that farmer can have an app on his phone that'll tell him, water it, don't water it, your moisture is good. So that's to help developing countries in agriculture and farming and things like that. So,
Assuming they have a phone, they have a, I mean, there are big.
well, I come from Africa, and I can tell you mobile phone technology in developing worlds is 10 times more advanced than what it is in Australia, just because everybody has a mobile phone. So I was in Manila, I don't know, 3 weeks ago, and the mobile phone technology and coverage out there, even though that they have people that don't have electricity at home, but everybody has a mobile phone. So in those type of scenarios, I think that's going to be a real big advantage for them. And these sensor networks, by the way, from that pole top router to the first hop, it's 23 kilometers. So you can have 23 kilometers, and then what will happen is you can have another 23 kilometers hop through another sensor, but they'll daisy chain, they'll hop through each other. So it's a really, really big mesh network, and the more devices you connect to it, the more they interact with each other and more they hop through each other. So it becomes a broader meshed infrastructure. So.
Look, it sounds fabulous, really, but it's about the underlying philosophies and social ethics and principles and values, and nothing. I think when companies develop that, it's like a smart city for what, for who, for what purpose, for everybody, yeah, it's exciting, but it's scary.
Well, definitely. I mean, even a really good question somebody asked me the other day. So what about all the data that they're collecting? And so, look, I've lived in places where people blow people up, right? More than once in my life. And if my council or my city had the ability to monitor and track in real time, not necessarily who the person specifically is, but how movement of things happen around the city, and understand that type of technology and use it to keep me safe, I tell you what, I'll live there. Yeah, any day.
And what about if it is used, for the opposite?
Well, there is that challenge as well, yes. But you always hope that the good guys are ahead of the bad guys, right? And they not always are, right? So that's just the world we live in
This is an
today.
interesting thing. It's like a technological arms race. All these things that we roll out create social disruption, which perhaps increase the chance of you getting these terrorists. All these people that lose their jobs because they were once truck drivers and now can't get truck drivers, and saying they're just going to jump up and reskill is a very naive. You say the hardest thing is privacy. I think the hardest thing is the social disruption to deal with and how you manage to transition that.
And the length of time taken to reskill people.
Yeah. Well,
Not everyone wants to work in this area.
Yeah.
Some of us are artists or want to get dirty or something. That's right.
but I mean, but isn't the reason that we're standing here is talking? I'm talking to an education institution, so I'm telling the reality that I know that's happening out there. And even if you take me out of the equation, believe me, there's 40 million people behind me that's doing the same thing as me. Intel has now got Intel has got an Internet of Things person in Australia now. GE has got one. I'm here. Every single organisation are putting people in place because I'll give you a really good example. So BHP Billiton put a statement out in the Financial Review about 3 weeks ago that basically said they need to cut 25% out of the cost of producing a tonne of iron ore. So producing a tonne of iron ore is somewhere roughly between $45, $30 or whatever it might be a tonne. So they want to take 25% of that. So if you look at the commodity prices, 2010, $197 for a tonne of iron ore. Now it's about $82. The reality is, unless they cut cost out by utilising technology to do this, they're not going to be competitive and they'll shut the whole mine down, then nobody will have a job. So that's the flip side of the coin.
These are the systemic problems that have been overlooked. You see this in farming, where everyone is in competition with each other, and the only way they can sort of, or their strategy is we have to get bigger and cheaper. So they start paying undocumented workers, they start using the cheapest chemicals, whatever they can to get the yields up, and the ones that go broke get absorbed into a bigger farm that says, oh, you know, I'll go on economies of scale. And this just, I mean, it's just a road to nowhere, this idea that, oh, we've got to cut by 25%, something else is cutting by 25%, then you've got to cut by 10 the year after, and then 10 the year after that. And it's, you know, there's underlying issues here which you guys are kind of exploiting and driving, you know, in a sense. And if anyone brings up questions, they're kind of shoved aside and said, well, no, this can't be stopped, you know. And it's an interesting sort of problem because, no, it can't be stopped, and maybe that's the issue. You know, it's not controlled. This is uncontrolled technology, and it's just a matter of same with the online. You know, someone decides it's good to have Facebook, it gets rolled out. No one knows the consequences until it's there.
Yep.
Once it's there, you can't pull it back. You know.
But I mean, the same can be said in the 1960s. The typing pool disappeared and everybody still had a job, right?
Rosemary, did you want to say something?
I was just, that's the very thing. My first job was I was a skilled typist, and I watched as all these managers were forced to learn how to type and use computers and things like that over 10 or 15 years, and watched a whole swag of people lose their jobs and reskill and all that kind of stuff.
Now we all have to do our own typing.
I know.
You use an app to translate to text. Look, it's don't feel.
No, not at all.
There are essential and philosophical questions that you need to ask. You need to think about.
Legislation. Where's the legislation around this? I mean, the Freedom of Information Act is based in 1982 in Australia. It hasn't moved on since 1982.
This
I mean,
is the problem. I think
yeah.
there are lags between industry and technology. Just it's like a.
And it's unbelievable at the moment. It moves so fast. Yeah.
I think we'll take one last question. Olivia, did you want to say something?
Yeah, something about the reskilling. Who's taking on the responsibility for that? Is it happening in industry? Is it happening in education?
Yep.
We've got a government that, you know,
So we.
slashing
Yep.
education.
Yep.
So
Well, the new one's not apparently. So. Cisco is taking a lot of responsibility in this space and reskilling people as well. We're bringing out actual changeovers, so we can actually take an IT guy that's never worked in operational technology, and we brought out a course on how to get him to understand what happens in that world when that amalgamation happens, that he can actually cross-skill himself. We're doing it the other way as well, that somebody's worked as an electrical engineer and has some understanding of IP, or internet and networking, that he can actually cross-skill himself into the other space. So so you know our Ccna certifications, we're bringing out a Ccna for manufacturing, a Ccna for oil and gas, a Ccna for utilities, a Ccna for industry. So 2 of them are already out, the industry and the manufacturing one is already out. So we are trying to skill people up that they actually have that cross skills across that as well. But yeah, and trying to work. and what we're trying to do is work very heavily in partnership with those organisations, the Honeywells, the Rockwells, the Schneiders, and those guys, to actually help them to skill their people up as well. You know.
And I think that's just to finish. I think that as educators, perhaps our role is really just to prepare students for what's ahead, as opposed to kind of just or just exposing them to what is going to happen, so that they're as prepared as they can possibly be. I think.
I hang out in the startup scene quite a bit as well, and the startup scene is an amazing place to be, and that is probably one of the fundamental things that people overlooked on how work and jobs and things can be created. I go to events that they create a new company in 58 hours and get funding for it, and I know a couple of guys that got $4 million, right? So there is a lot of that type of stuff going on out there, I think. But waiting for the government or waiting for somebody to create a job, that's not going to happen anymore. It's a fundamental shift that's happening in the market space.
As educators, I don't know who's our teachers in the room, but as educators, we need to be thinking about, 10 years down the track, I won't be standing in front of a classroom 20 hours, or in their classroom 20 hours a week. How do I position myself so that I'm more employable, or I actually create my own work?
Yep. Well, look at one of the biggest disruptions. Sorry, I don't know the gentleman back here. One of the biggest disruptions that the internet had and digital media was to the printing industry in America. There's unbelievable documentaries that I've watched on what's actually happened in that industry, and I've seen some of the people that used to work for small newspapers and small councils in the middle of heartland America now are some of the best bloggers, and they've actually changed they're still writing, but it's not on print, right? So that there is every single organisation, every single industry is being disrupted at the moment. Believe me, Cisco is being disrupted. We are being eaten by 1,000 small fishes, not one big whale. That's the difference, right? That's how our industry. We have startups that are coming up like that. That's doing the technology that takes us years to do. They do it in 6 weeks in a garage, because it's become so easy to deploy the technology, right? And it's so cost effective, and that's the big change. So even we're being disrupted very heavily. So, yeah.
Anyway, thank you very much.
No, it's a pleasure. Thank you very much for your time.
This has been a Swinburne production.